Hello, today we're going to name a few organic compounds. We're going to talk about naming conventions in organic chemistry. So if we start with simple alkanes, we can use our structures that we drew last time, so we can draw them longer and longer without drawing the carbons. They're on the corners, and without labeling the hydrogens. They are implicit, so each carbon is saturated with hydrogens unless it's got a double bond or a charge on it. So if we start simply with the naming of linear carbon chains, we have a few weird ones at the start, which are methane for 1, so 1 methane, 2 ethane, 3 propane, and 4 butane. Propane, ethane, and methane. Often in organic chemistry, they're not in focus, weirdly. Often in organic chemistry, it's shortened to Me, Et, Pr, and Bu. If we go further, we end up with Latin prefixes to the names, so we have pent for 5, pentane, hexane, heptane for 7, like the heptathlon, octane, nonane, decane, undecane, duodecane, and so on. So those are our linear ones. If we want to name a compound that contains hydrocarbon chain, we have to find the longest chain, and that becomes the name of the compound. So if we take something like this, 1, 2, 7, 8, so that will be octane, and let's put some methyl groups on it. So those are 2 methyl groups on there. We would name the chain octane. We need next to arrange it so that the substituents, the first one that we're going to name, are at the smaller end, have the smaller number. So if we number it from this end, 1, 2, 3, 4, 5, 6, 7, 8. Ooh, it's not octane, it's nonane. This would be 3, 3, because there are 2 of them. Di, because there are 2 of them. Whoops, sorry about that. That's also out of focus. Dimethyl. Whoops, dimethyl nonane. So here we have another molecule that we need to name, and I've turned it round. I should have really drawn it the other way around. This is our longest chain. So this is the longest chain in the molecule. Sometimes it's harder to see than that. This direction is shorter. So here we go along, and if we number it to keep these at the left to have the smallest number, 3, 4, 5, 6, 7, 8. Let's have 8 this time. I keep drawing too many. So this would be 4 methyl. Oops, let me put it up where you can see it. This would be 4 methyl, and then 2, 3 nonene. Oops, not 2, 3. No, 2 octene. So this double bond is on the 2 position. It starts here, and the methyl group is on the 4 position. So we have 2 octene is our core molecule, and then we have a methyl group on the 4 position. So we can construct it from the back. 2 octene is our molecule, and the 4 methyl, because there's a methyl on the 4 position. So if we search on Google for naming compounds, we get a site. I've just gone out to have a look where it is. It's the University of Illinois. Here it is, UIUC. How to name organic compounds using IUPAC. What you may be familiar with from school is isomers. So if we take something like butane, methane, ethane, propane, butane, that would be normal butane. And if we take this carbon, so instead of putting it on the end here, and we put it in the middle, this would be an isomer of butane because we've moved one of the bonds. This is the same, it has the same number of carbons and the same number of hydrogens, so this is CH3, CH2, CH2, CH3, giving us 3, 6, 7, 8, 9, 10, so it's C4H10, and this is 3 CH3s, giving us 9, and there's only one hydrogen on here, giving us also C4H10. Because there are no other isomers of butane, this can be called isobutane. So you might be familiar with that from school. Let us think about these for a little while in a little aside. So if we take a compound and we move the bonds around and we have the same number of atoms in it, we get an isomer. They have the same elemental constituents, but they have a different structure. Depending on convention, they're called structural isomers or constitutional isomers. So we have the isopropyl group, where the connection to the rest of the molecule is on the middle. The normal propyl group would have it on the end, methane, ethane, propane, and then here, X. If we go up one to the butyl group, they have more. So we can have the normal butane, 1, 2, 3, methane, ethane, propane, butane, and then the bond. Let's call it R because it often is called R in chemistry. So this is propyl, and this is isopropyl. This is butyl, and we can see there are more possibilities with butyl. We can move an end group to the middle, or we can move our substituent to the middle. So if we move our substituent to the middle, to here, we would get the isobutyl group, butyl group, and if we move the substituents all around so that we've got 3 of them, and our R is on the middle, then we get what's called the tertiary butyl group, which is very common and important to organic chemistry, and it is almost always referred to by its sort of common name. So to summarize, we need to find the longest chain in the molecule. We need to number the carbons in the chain. So if we have a molecule like this, let's have a long one here, we need to find the longest chain, which would be this one. So it goes through to here, that would be the longest possible chain, and then we need to number it to get the smallest numbers for the side chains. So we should start here because there's none down at the bottom. So we go 1, 2, 3, 4, 5, 6, 7, 8. So this is an octane. I keep drawing octanes and nonanes, but anyway, so this would be octane. Then we have the side chains, which would be 3, 4. So 3, 4 dimethyl. Octane is this example. So we find the chain, orient it so that the substituents that we're going to have first have the lowest number, and then work out what we're going to call them and give them their numbers. If it has a double bond oxygen on it, it's a ketone or an aldehyde, depending on whether it's in the middle or on the end of the molecule, and then it gets the suffix -al or -one. If there are more than one of these special substituents that change the name of the molecule, so double bond O, single bond OH, several others, acids, esters also do it. If you get one of those, then we also have to order them, and there is a table. So if we do that, just to finish off here, we can see in this particular website that I found a Master Organic Chemistry, masterorganicchemistry.com, nomenclature. we can see first of all it's got a table of functional group priorities, and we can see the first one would be, in the table is the carboxylic acid, is the acid group, and that's called oic acid typically. So here's the example, ethanoic acid. Then we have a sulfonic acid, which is relatively rare, ester groups, acid halides, amides, which have an oxygen and a nitrogen. Table continues, nitrile, a triple bond nitrogen, so that will be called nitrile. The suffix is here, so this would be the ethanoyl chloride. These are the examples. So this oil halide, the halide will be chloride or bromide or iodide. If we go down here, this is the aldehyde, so this is anal. This is a ketone where it's not on the end, so this is propanone. 2-propanone, it's the correct name for acetone. Methanol, so the alcohol, thiol, amine, and it goes on. So that's it for naming. We'll come on to a different type of isomer as configurational isomers next. See you next time.